Alright, so we are now down to the detectors or transducers. So basically, ang detectors ng optical spectroscopy can be divided into two. You have your photon detectors and you have your thermal detectors. Ano man yung pinagkapareho? So, yung similarity would be both of these detectors, no, being transducers, converts light signals into electrical signals, no? Either as voltage, as current, or as resistance. Okay? So the increase or decrease in voltage, current, or resistance is interpreted as a measure of the intensity of radiation hitting the detector. So basically, again, you're measuring here the intensity or the power of transmitted light. Now, photon detectors, as the name implies, detect radiation as photons. And this is only possible if the the transmitted photons are energetic enough. So this type of detectors are commonly used for UV-Vis instrumentation. However, if you're doing IR spectroscopy, IR radiation is not energetic enough to be detected by photon detectors, no? So alternatively, you can use what you refer to as your thermal detectors, which senses radiation, no, as heat, no? So remember, IR radiation can be perceived as heat. All right. So common photon detectors muna tayo, no? So first you have your phototube. So basically, the principle of phototube is yung photoelectric effect, no? So when photons hit this cathode here, which is electrically biased, okay, against a 90 volt, for example here, a 90 volt voltage, it produces a current, no? An electrical current. So the current produced is directly proportional to the amount of photons hitting the phototube. Okay, a related detector is your photomultiplier tube. So the design is similar to your phototube, except that it contains what you refer to as dinodes. Yeah, dinodes, no? So the dinodes actually multiplies the emitted electrons. So kung tumama kunwari isang photon dito sa first dynode, the first dynode will multiply that the photon, no, equivalent to 2 electrons kunwari. So these 2 electrons will hit another dynode, which will convert those 2 electrons into 4 electrons, then so on and so forth. So it multiplies, alright, the number of emitted electrons per photon, okay, interacting with the detector. And this is one of the most sensitive detectors, no, photon detectors, and it's commonly used in fluorescence detectors, no, and even AES, no, AES. So those equipment that requires higher sensitivity would usually choose photomultiplier tubes. Okay. Next, you have your silicon photodiodes. All right. So a diode muna tayo, no? So a diode is an electrical device that allows the passage of current in one direction only. All right. So if you have a forward biased photodiode, so makikita dito that the current is allowed to move only in one direction. But if you have reverse bias, your diode becomes a resistor, alright, which prevents the flow of electrons. Now, this is the one being used as a photo detector, no, photodiode. So, with a reverse bias silicon photodiode, since you have reverse bias, you have low conductivity, so high resistance, no? When light hits this detector, you are feeding electrons, no, energy, no, coming from the light. So you're feeding electrons in the depletion layer, which in turn reduces resistance. Okay, because of these added electrons, you significantly increase the current flow, no, and hence lower the resistance, no? So this reduced resistance, or actually equivalent to a voltage drop, is interpreted as the measure of the intensity of the radiation. Okay. Next, you have your photoconductive cells. This is quite unique, no, because this is a photon detector which can be used for infrared spectroscopy. So normally, the light-sensitive material is made from a ceramic, no, lead sulfide, or more commonly, yung tinatawag na MCT, no, mercury, cadmium, telluride. So these are ceramic material. So basically, what happens that when light hits the light-sensitive material, it causes photoconduction, no, or an increase in the conductivity of the material. So this is again interpreted as the presence, no, and the intensity of the transmitted radiation. Next, you have your photodiode arrays, no? So these are silicon photodiodes that are arranged in an array, no? So pag sinabing array, so for example, this two-dimensional array here, you have here individual diodes, no? Okay, so this is used for the simultaneous detection of transmitted radiation across several wavelengths, no, or if not all the wavelengths, no, used, no, for the analysis. So this is usually used for instruments, no, well, we call those multiplex, no, multiplex designed instruments, no, wherein you want to simultaneously record the information coming from various wavelengths, no, at the same time. Alright, so yun yung significance ng photodiode. Okay, so yeah, as you can see, no, from this diagram, if you're using a photodiode array for your monochromator, you don't need an exit slit. Okay, so you don't need to filter one by one pa, no, yung lumalabas na radiation, because you have a detector capable of reading simultaneously this different wavelengths, no, the information from different wavelengths. So similarly, you have your CCD, charge coupled devices. All right, this is similar to a photodiode in concept. The difference is that this one is more sensitive, no? So you have a two-dimensional array with each of these squares, no, you call them pixels, capable of receiving and detecting radiation, no, across different wavelengths also. Okay, and this is commonly used in inductively coupled plasma. Okay, now this type of technology, similar ito dun sa nasa cellphone yun, no? Kaya nga yung rating ng cellphone camera is based on pixels, no, or megapixels. Okay, pictures are formed because the detector for your digital camera in your cell phones, okay, contains this similarly constructed detector. So each of the pixel will record each of yung part ng figure na pinipicturean natin. Alright, so the more pixels you have, the highly resolve yung photo na mapoproduce. Okay, so next you have your thermal detectors. Okay, so first one, you have your thermocouple. A thermocouple is basically made from two dissimilar metals. So may dalawang metals yan, no? Metal 1, metal 2. Metal 1, metal 2, which are dissimilar. Okay, now when exposed to heat, okay, they have the tendency to produce voltage. Okay, they produce voltage. So ito yung basis nung thermometers, no, na used in yung mga digital thermometers, no, sa medical applications, or yung mga sinaunang ovens, no, kitchen ovens, no, na merong built-in thermometer, no. They are based on thermocouples actually, no. A more modern type is yung tinatawag na bolometer, also called your thermistor. Okay, so for a thermistor, the response would be a change in resistance, okay, with respect to the presence of IR radiation. So this is the electrical setup, no, for a thermistor. And then next you have your pneumatic detector, no? So all of these three were used in IR spectroscopy. So for the pneumatic detector, basically you have here a gas filled cavity, usually xenon. Okay, so pag tumama yung IR radiation, the IR radiation will heat up the gas, causing this membrane with the mirrored surface to move due to the expansion of the inert gas here. So the movement of this membrane is detected by a parang photo setup, no? So you have a light source and a photo detector here. All right, so this tracks the movement of the membrane, no? And this is interpreted as the intensity of the infrared radiation. Now all of these three are not used nowadays, no, in IR spectrometers. Okay, hindi na sila ginagamit. So ang ginagamit ngayon sa IR spectrometers is either the photoconductive cell, which we showed earlier, or this one, no, this what you call a pyroelectric detector. So a pyroelectric detector is a type of device that produces voltage, okay, once you heat it up. All right, so pyroelectric detectors are more commonly used because they have faster responses, no? Yung unang tatlo kasi they have very slow detector response, no? So pyroelectric detectors have better response times. Ang pinaka-common na ginagamit na pyroelectric detector is yung tinatawag na deuterated L-alanine triglycine sulfate. Okay, so you read it up, no, sa textbooks ninyo.